Okay, good morning, good afternoon, everyone. Thank you for joining the 3DOptix webinar for 2024. This is the first one, one of many others that will come later on this year. We're very thrilled to announce new features that are already released and are in the production, and you can enjoy them right away. And I will mention a few other features that are planned to be released in the next several weeks. Those are exciting and provide enhanced capabilities in this session as well. So without further ado, I will start by sharing my screen. Okay. Good. So the first thing that I would like to introduce is the 3DOptix API. If you go to the 3DOptix webpage and you go to products, and there is an API integration webpage, and this is this page, explains everything about our API. Our API are Python APIs, and you need to download an SDK that you can find on PyPy. And if you scroll down, there is here a link, and you can go to the PyPy. So there is an explanation here. You can download the SDK. And the SDK of Python is an add-on to the GUI. You can use the GUI to do all kind of operation on the design, but you can also do it with code. And we already started to see people that are doing optimization processes, simple ones with Python code, and doing some scanning with Python code. And this is just the beginning of this amazing revolution that would lead to a lot of amazing use cases. One of them can be synthetic data generation for optics, but you can start exploring our APIs. This is a feature that is available for our premium users. So this is the first notification. The second one is that we have released the first Gen AI chatbot, or Gen AI Copilot for optics. It currently resides under the catalog product search, and it interacts very nicely with this. So if you open this, so you can see some examples of what type of interaction you can do with this Copilot. You can either ask like generic question, like help me understand the basic of optical system aligned and calibration, or do a specific search for grading and grooves range between 100 to 200 lines per millimeters, or even do calculation with that, because our chatbot knows to do optical calculation as well. And each search that you do, you can see that this windows pop up. The chatbot thinks, and then it starts to iterate. You can see they found 64 grading matches, and you can see that the optical catalog now turns in sync with what you have here in the chatbot, and helps you to find the right product. I want to show you. You just share another screen. I would like to show you how you can interact even more deeply with this chatbot. So we start here. This is a video, and I'll show you what it is. So you are opening the catalog, the product catalog. You open the chat box, and you can see the first question. What are the materials with a refractive index close to 1.456 at 506 nanometer? I recorded the video because it's going to be faster to show you the result. And you can see that the chatbot already found about 10 materials, and with some deviation for each and every material, and it explained what the deviation is all about. So the deviation value represent how much the refractive index of a material, etc. Now, the next question is, I'm pausing for a second, is UVFS is a good match? What is the radio of a convex-convex lens made from UVFS that will create an EFL of 20 millimeter at this wavelength? And you can see what the chatbot actually answers. So you can see for a convex-convex lens made from UVFS, that will be create an effective focal length of 20 millimeter at 560 nanometer. The radius of the lens would be approximately plus minus 17.42 millimeter. Please note that a default central thickness of 5 millimeter was used for this calculation. So I'm continuing with the interaction. So can you search for those lenses with the tolerance of 0.5 millimeter that fits what the chatbot found? And you can see that what happens is the chatbot answers. So I found 5 lenses that match this criteria. With the 3 parameters like the material UVFS, the lens subtype, spherical lens, and the radius range from 16.92 to 17.92. And you can see that the results now are presented here in the tab. And those are the 5 results. The results are presented. And now I would continue interacting with those results and narrow down my results to a single result, and then I'll add it to the canvas. So narrow it down for only, if you see, just a second, let it finish. So I asked him to narrow it down to only uncoded ones in a new tab called Awesome Lenses. So it opens a new tab. Keep in mind that it saves in a different tab each and every session that you have with him. So I asked him to open a new tab and put the one that is uncoded. And we found here the result. And what will happen next? We will mark it and add it to the canvas. So I'm writing, thank you. And the bot replies, thank you. And I'm adding, see, you're welcome. And now I'm adding that specific element to the canvas so you can see it in the canvas. Now, when I open now again the OptiChat, specifically here in the same design, so it saves the previous 2 sessions with this 2 new tab. So the first thing that I'm telling him, open another tab with ball lens that will create the same EFL at this wavelength and material. So you would see immediately, after he thinks, he opens a new tab, ball lens search, finds one option, and this is what he's writing. So here are the material parameters. We select this ball material and we add it to the canvas. So this is the first product, I think, worldwide that is doing AI for optics. This is ChatGPT, but on top of it, awareness for optics. This is what we have developed. And you can do straightforward searches for optical product, but you can also do much deeper calculation. And later on, we are going to introduce much more fascinating things that will help you to do easier and faster and more accurate designs. So this is the chatbot. This is available to our free users as well. Okay. Now I want to present some more new features. And for this, I'm going to ask Roman to present those new features.
My name is Roman Bander. I'm a product manager of 3DOptix. And I will present our webinar where I will show you new features. Actually, this webinar will summarize last 2 releases, version 3 and 4. And this will be the outline and our talk today. I'll show you how to create a user-defined coatings. The next topic will be CAD objects, whether it's optomechanical or optical CADs. I'll show you how to modify the faces or surfaces, color and transparency, and also how to apply these user-defined coatings I just showed you in topic number 1. The next one will be nice features we added to our actually post analysis. Now you can scale the X and Y axis ranges like you do in Excel, for example, or MATLAB. And also like you do in MATLAB, you can change the color map of your image. Next topic will be our new features of uploading apertures, or we can call them masks. Then we will talk regarding a move and rotate dialog. The same one we recently used, but we added new features. So you can lock, for example, you have some important element which you would like to prevent from accidentally moving. You can lock it and then of course unlock. And also you can dynamically control or change your increment resolution. I mean, minimal steps by what your element will be moving. Also in the general settings, you can, like in Zimux, for example, you can change your decimal accuracy settings. The default will be 4 digits after decimal point, but you can modify it. I'll show you how. The next one will be a nice feature which will now allow to change how you control your ray colors palette. So you can modify what will be intensity threshold for visualization only, the rays you see on the layout. And also we add the new features that your rays color mode or colors palette will be now in logarithmic mode. So weaker rays now will be visible. Number 8, a new camera view is the same one, but we added a new dialog, which is from user experiences much more flexible. You can move it, you can change the views. And now when you download the image, your last point of view and the zoom will be preserved. You will see how. Number 9 is bomb creator. So for some complex system, if you model something on your breadboard, and then you would like to go to the laboratory and create it, you can by click of your mouse, create a bomb PDF file with the elements part numbers, if they are from our library, and the vendors' names, and you just can go and order from the internet, for example. And the last one I would like to talk is quick snap to the center of beam. So now every element, not only with the optical element, but also the detectors, for example, can be snapped to the center of beam. So this is some useful feature. You can just easily position your element. So let's start. The first one is a user-defined coatings. And I will just show you, I pre-populated this file. So this is actually the same lens. And if you go and look at the properties of the lens, you can see that this is a Q-optic lens. You can, of course, click here and see a vendor website with the details. Of course, geometrical properties you are all aware of. But now let's talk about user-defined coatings. So go, for example, for the front surface, and it is uncoated now. If you would like to coat, this is an old feature. You can go to our preset coatings, which is total absorber, ideal reflector, variable beam splitter ratios, and ideal broadband anti-reflection coating. But now you can create your own one. What you should do, you go to the custom file, you click on it, and then you need to download our template. You will see it's now downloaded. I'll show you how it looks. You'll see it is a very simple Excel file, which you see every line is wavelengths, then transmittance in P, reflectance in P, and the same in S. And you see these are just the examples. So you need to populate all of this list for the wavelength range of the light sources you will be using. So in this case, I already did it and created from 400 to 500. And as you can see, what they do after you pre-populate and save it, you choose your file by browsing, and you go, I called it custom coating, and then you import it, and then you can see your coating chart, and then you see it's exactly what you saw in the template. I just populate for all the range from 100 to 500, and then you just save or save as if you want to change the name of your lens, and then you see this lens now it has different appearance because of the coating applied, and it's the same one. I just added the coating before. So this is how you do it. Okay, you go to the surface, for example, from here, you pick up your surface. This is the front. You see it's already applied. You can apply it to the back. You can apply different coating, but you can apply the same one. Just browse. Remember, it's custom coating. Import, save. Now your lens will have both surfaces coated. And of course, everyone can be created. Just define your transmittance and reflectance in a P and S polarization states. Okay, now let's move to CAD objects, where I show you how to change the appearance and the same, how to apply user-defined coatings, the same we did for a glass element. So this is the file, and this is the step file of some controller, which I pre-uploaded. What you can do is just the same. You can, when you hover over the objects, just right-click, and you see the cut settings. Now, what you can do, you can apply surface properties for all faces, and there are a lot of faces in this specific example. Or you can choose face to change its properties. Then, when you hover, the faces will be highlighted. And for example, you select this, the front one. Then you see the color information, and you can change it. You would like to have it red, it will be red. And just let us save. Okay, now it is red. And what you could do also, you could the same one, or let's do it for another one. Sorry, let's hover and cut settings, choose face to change the properties. Now, this one, let us change it to have different opacity. Let us do it semi-transparent. Let us see what it will be. It takes a bit because the step files are heavy. Let us check again. Okay, now this is semi-transparent. Okay, now in the same manner, what you can do, let's select the same one, the front one, which we used before, choose face, I choose it again, and go to the coating. Now it's ideal broadband reflection, but I would like to have it totally reflector, okay? And let us save, and let us propagate the beam. I just click the propagation simulation. So I expect it to be mirror, and you see what it is, okay? So I shall change, and of course, you can do the same trick we did a few minutes ago. You just go to the custom file, and you just upload the same one we used before, and it should do the same. Of course, it's not a lens. It's a mechanical surface, but actually you can define that it will be, for example, 90% reflecting only, and it will obey. It will obey what happened there. Okay. Another features that you can do exactly the same you do to the optical surfaces. Let's go again for this guy. Let's move it reflector, but now let's apply scattering, and let you know, if it is reflectance, so it will be 100% reflectance again. Okay, it's automatically now 0% transmitters. It is Gaussian, default 10 degrees, and number of scattered rays, let's go for 5, so it'll be less heavier. And now save. And now we need to propagate the beams, and let's see what happens. Again, it will take a bit time because it's getting heavy, and you see what happens. Instead of just reflecting, now it is scattered. It can be very helpful in, for example, ghost or stray light analysis, when you can define, when you have the optics, for example, some objective lenses, and then you have your barrel of the mounting, the holders of the lenses. Now, in the inner surface of the barrel and the mountings, you can define, which are CAD objects, objects which are uploaded before, you can define now to be scattering, whether Lambertian or Gaussian. You can define how much percentage will be reflected, and then you can analyze and simulate your real system performance in terms of straight line. Okay, our next object will be analysis. Let me show, I just will close these guys because we're already done with it. Now this analysis, you remember in the past webinars, I showed you how to use a Mach-Zehnder interferometer, where in the one of the arms, I added a window just to see nice fringes. And you see that the fringes are shifted. You remember this picture? Because the thickness which I chose and the material should be half period shift, and you see. But what can you do now? What is the feature I present now? If you go to the cross section, what you can do, you see for this example, not all of this is pre-populated because the image is actually smaller than the detector. So what you can do, go here, adjust axis ranges, and you see the whole range from -12.5 to +12.5, which is a detector full size, 25 millimeters. But now it can be from -5, +6, for example. And also, you see, you can change the Y to be to 1, and then and this is what it does. Okay, of course you can do it to download. You just download Excel and you can do it in Excel, but it's much easier to do it here. So this is one of them. Another one, you see here, the contrast is nice, but if you hover all the bright areas, you will see the value at the bottom of the image, and you see it's normally around 1, maybe 1.2, while if you see at the color map, it's 178, because there is one hotspot, and automatically your image is scaled to the maximum. But sometimes you want to see your maximum contrast and you would like to ignore the hotspot. So in this case, the same as you did for the profile, you go here, you see the just color map range, you will see it's 178, which is the maximum. But for example, you can do it 1.2 and then okay, and see how brighter, how high contrast your image is. So you can use it in the same feature, a similar behavior to what you do with color map in your MATLAB analysis, for example. So let me show you. Let me just close it and proceed to the next topic, which is a move-rotate dialog. I mentioned log and dynamic increment resolution. I would like to use the same file I already showed you, which is user-defined potence, but it doesn't matter. I would like to show you just a feature. So I select the lens, and then I go here to move rotate. Same one we always use. But now, if I click here, look, moving rotate, see what happens. I cannot move it manually. I tried by mouse, and I have this node. That is locked. The same if I do it here, and I try whether by arrows or change here to another number, it will prevent me of doing it. Okay, so your important elements which may be a pivot for other elements or just very important to keep them, and you are confident that this is the proper location, can move, lock the move and rotate, and then of course clicking here, you unlock and then it is moving again. Now regarding the increment, what we did, look here, we decided it will be very comfortable and useful for users that it will follow, the increment resolution will follow the current state. So here, when it's 100, without numbers after the decimal point, it just will move by unity, you see, move by 1 each time. But if you go here for x, which is 0.681, moving here will move by 1 digit, 682, 683, etc. Okay? So and of course you can change it if you would like here to be now having 1 digit, go for delete the digits, and then it will, you see it is moving now by a 0.1 millimeters accuracy. Now in general, you can change your decimal accuracy here. You go to user settings. You can change it for for setup only, or you can do it globally. Now you see the accuracy is 4. This is just a default. I can do it for 2, then save. Now let's move, see what happens here. And now see it's only 2 digits. Okay, so this is what if you want to have more 6 or 8, it's not limited. Just go to your user settings and change. Okay, so I also covered now decimal accuracy settings, which is general, and showed you also how to lock and rotate your move, lock your move and rotate, sorry, and also how to dynamically change your decimal accuracy. The next one will be ray colors palette, which will be visualization intensity threshold setting and use logarithmic scale. So let us open. Should be multi-reflectional setup. What is it here? I have a window. I use the settings and I defined from front and back in simulation setting. I checked out no reflection. Now to have 20 bounces in sum from back and front, because I want to see them all. Now you see, if you go here, you're familiar with color palette. There is a spectral ray colors when you see it's in the rays because it's green. It's 550 nanometers light source. You see it's in green, but you'll see the weaker the beam, the weaker the green will appear, and log will be enhanced. You will see, and intensity is the same, but just you see the brightest or the strongest is red, and then it go to blue region when it becomes weaker. And we have also the directional ray colors, and we can have using defined colors. I'll show you with scope triplets, so you can define for every light source what will be the color of your rays independently of the wavelengths. Okay. So now, why you see only, I promise you 20 bounces and you see only maybe 7 or 8. This is because in user settings, we have intensity threshold. This is a general feature. This is intensity threshold for your layout and for your analysis. So rays under this number of intensity, relative intensity, will not be propagated. Okay, so if I put, for example, here some small number, let me change it. it again. The second guys, back to your question. Much better. Some very small number. And please pay attention. This is an intensity threshold, and I'll show you in a second what is visualization. Visualization intensity threshold will affect only your layout appearance, while intensity controls everything. Okay, now I save, and now let's propagate again, and let us see what happens. Okay, and you see, maybe you don't because the rays are very weak. You know, it's 4% reflectance from the first surface, and the next bounces are even weaker. So we see very weak green because we are now in the mode of spectral ray colors. See what happens when we go to logarithmic one. We see much more. I'll show you how we can see the bounces, but please note, if we go to directional ray colors, you will see all the bounces, all the 20, somewhere 10 per each surface. Okay? And the same, will happen for the user-defined colors, and they're green. So by default, your user-defined are the same as for the wavelengths. You can see it here. You go to your light source, and you see in the appearance that it's green because it's 550, but it can be now red, for example. And then let's see, spectral, now user defined, and then let us propagate it. Okay, I didn't change it properly. Red, okay, now see. Okay, but now let us go here for example, intensity based. It's shown from I just don't see all the bounces. Why is it so? So the reason is, again, in user settings, you can see that I change the intensity threshold. Now, very weak beams will be propagated, but they will not be visualized on your layout because the visualization intensity threshold still not very sensitive. Let us go and not let us do it in this mode, also -6. Okay, and let us save, and now let us propagate, and now you will see all of them. This intensity mode. A second to render, yes, and the same. If you go to spectral ray colors, still you will be seen on the first and the second one because they are weak. But now you can go to the spectral log and see much nicer. You see almost all of them, which again, you can see all of them if you go to the intensity one or to directional user defined. Okay. So this is the topic I covered, how we change visualization intensity threshold and using logarithmic scale. The next one will be a new camera view. And for this one, I would like to use, trigger also some old example, so familiar. So now if you would like to approach your camera window, you click here on the left bottom, see the eye, and you click. Now the dialog, this is the new one. The dialog will open, and then you can drag and put it where you want it. And then when you change, you see by right mouse click and dragging, you see the scene angle. You see how dynamically they are updated in the camera view window. Okay, so this is This is what you can do, or you can just put here, insert the number, and it will be updated.